In the final activity of the wireless burglar alarm module, we're going to give the students recordable greeting cards so that they can record sound to go with their alarm systems. With that ability, students are going to then be given the design challenge of designing an alarm system for a particular purpose. Engineers always design for a particular application. Theirs might be protecting a lockbox in a room, it might be protecting money in a bank, it might be protecting a barn so that somebody doesn't come in and steal something from the barn. Whatever the students want to protect, they must design a system to protect that. They should draw their designs on paper and then use the wireless or wired transmitter and receiver circuits created in activities 2 and 3, combined with 1 or 2 door trigger circuits in order to develop an alarm system that both scares somebody away with a warning and warns them of the intruder.
In this activity, we want to replace one of the switches on our transmitter breadboard with our door switch from activity 1. First, we remove both of the wire ends that feed into the switch and point them upward. Then, we remove the switch from the breadboard. Lastly, we attach alligator clips to these 2 free wires. These alligator clips will be attached to our door switches from activity 1. When the box is opened, the LED on the receiver will turn on wirelessly. Students may find it easier to attach the alligator clips directly to the aluminum foil rather than to the wires. This is okay too. The sound devices we'll be using will come from recordable greeting cards. Your cards may be a little different, but the basic principles will be the same. If you open yours up, you'll see all of its contents laid out in front of you. The 2 large silver discs control the recording mechanism. When you push down on both discs, you'll notice that a red light turns on. The red light indicates that a message is being recorded. To erase the message and record a new one, push down on both discs and say your message. To play the currently recorded message, press down on the silver tab located on the green chip.
And say your message.
To add these sound devices to their alarm systems, students should first bend this metal tab upward. One alligator clip should be attached to this metal tab, and the other should be attached to the metallic part on the green chip. The sound device can then be attached to a door switch the same way as the transmitter was previously. When the box is opened, the recording will play.
Stay out.
In order for the students to have their lights flash and their sounds play when the box or door is opened, they'll need 2 switches, one attached to the transmitter and the other attached to the sound device. After all of this is set up, when the box or door is opened, the lights will flash and the recorded warning will play.
Stay out.
The purpose of this activity is to get the students to really think about how their burglar alarms will be used. So, if they finish all this and they have some extra time on their hands, let them explore ways in which their designs could be improved. For example, students may want to hide their alarm systems by placing the switches and devices inside the box. Others might work on reinforcing the aluminum foil contacts in order to make their switches sturdier and more reliable.
In concluding this activity, have students describe to their class how their designs work. First, ask them to describe what problem they're trying to solve with the alarm. Second, have them demonstrate their alarm system for the class and explain how it works. Why did they choose to use the sounds as they did? Why did they choose placement of the system and the trigger as they did? Finally, have the students explain how they would do it better next time. This might be both with the same materials they have, or if they had better materials. What would they do if they had a more powerful transmitter? What would they do if they could make the receiver waterproof? What would they do if they could make the receiver more durable? These are the types of questions that an engineer might ask, and we want the students thinking about how they can make the best system possible.